Please start heading this way. Dave is a director in Cisco's Advanced Technologies Group, I believe, something like that. And it's at the University of Oregon, and is going to be talking with us about LISP and making routing scale into, the next decade. So.
Thanks, Bill. Okay, so this talks about LISP. I wanted it to be mostly about what we've deployed and what our practice and experience is, but I want to give you guys a little bit of a background first. So I'm going to try to go through that as fast as possible so we could talk about what's out there right now. But I also did want to say that this list of people here are all active in the development and deployment of LISP, so it's a kind of a teamwork thing. So here we go. So here's my agenda. LISP in a nutshell, that's the part where I want to tell you about, what it's like, what it's really all about. If you're not living this day to day, it can seem kind of obscure. And then I wanted to show you what we put out to the field, some about the deployment model, how we're trying to build names and numbers, how you might configure it on the router, on your router, what we're doing future-wise, a few open questions, what our active drafts are if you want to read them, and then some Q&A if we have time. So what is it? Locator ID Separation Protocol, LISP. How many people have been following this locator ID split technology issue? Raise your hand if you have. Okay, so let me just say this. At the 10,000 mile view, the idea here is IP address overloaded with both location and identity. Since routing really has to follow addressing to scale to be aggregatable, there's a tension there. So the idea is that if you split location from ID, then you can get the core side of the routing to scale better because you can have it more aggregatable. And then on the sort of the ID side of it, you could also get that to aggregate because you can decouple it from the topology. And we'll see how that works in a second. So that's like the 10,000 mile view of what the hope of the locator ID split thing is. So we have endpoint identifiers. We call them EIDs. This is our terminology for numbering hosts. That's what like you'd look up in the DNS when you try to resolve a name. We have topological routing locators. That's what's in the core right now. Those don't change. And then LISP is mapping and a map and encap solution. How many people have heard that before? Okay, so we'll see what map and encap means, but basically if you want to have two number spaces and you only have 32 bits like you have in IPv4, you got to put another header on to get the other bits. So that's the map and encap part, but we'll see that. We tried to build something that didn't require host changes because host changes always seem to be something that slows us down a lot. No new addressing in sites. We want sites to be able to use their own addressing schemes and devices. Trying to keep the configuration down, and we'll see that. We wanted it to be incrementally deployable and address family agnostic, so IPv4, IPv6, MAC addresses, whatever. There's tutorials on www.lisp4.net too, if you want to see more of that. Some of the talks that we've been giving around. There's two new network elements here too. One's called ITR, ingress tunnel routing. This, by the way, this terminology has kind of found its way into the lexicon of all of this, so it's pretty standard now. But basically, this is the device that sits on the edge of your network that finds the EID to RLOC mapping. That's the map part of map and encap. And then it encapsulates to the locator, the RLOC, at the source site, and that's the encap part. And of course, it sends it across to the other end that decapsulates it. That's the ETR, and then sends it on to this location inside the site. So ETR and ITR. Think about the ITR is the thing that does finds the mapping, does the encapsulation. The ETR is the thing that decapsulates it at the destination site. One other thing about that is we've kind of taken to this terminology that we call XTR, like you'll see this sometimes, a little XTR. The X is, we just use X when it's both an ITR and an ETR, which is pretty common. So here's how the LISP data plane works. This is the map and encap stuff. So throughout this talk, we'll try to keep the EIDs are always the green things, and the routing locators or the RLOCs are in red. And in this example, there's a mapping entry in the ITR S1 and S2 that it doesn't matter how it got it right now. It could have been static. It could have learned it through a mapping system or whatever, but it has a mapping. And basically, that's, let's see. we have a laser pointer here? Will that work? No. Will it? Yeah, will it? I don't know how to use it. Okay, that's all right. Yeah. So basically, this mapping entry, see where it says mapping entry there? That mapping entry basically says if you have this prefix, EID prefix, green, 2/8, then when you're encapsulating it, send it to the routing locator 12002 or 13002 with priorities and weights. I'll explain what that is later, but just for now, imagine that either of the ITRs on the left side have that mapping. So what happens is this host S wants to send a packet to the host D. Host D's address is 2002. It just looks that up in the DNS like today. So it gets a DNS entry, and now it's just going to send the packet like it does today, right? And what it does, oops, that's not so right. So I think this animation got crushed out of here. I might have to just talk through that. Okay. I guess there's no animation in here. Let me just talk through it then for you. Basically what happens is the packet gets sent from S, gets to S1 and S2, either whichever one, it's IGP routing takes it to. Say it's S2 in this case. What S2 does is it encapsulates it in the routing locator that it chooses for this particular one, and it does that by hashing into the mapping entry. So what it does is it puts a header on it that says, okay, the destination is 12002, which is the EID, which is interesting. We're going to send it that way. And the source is actually the routing locator of the ITR. Thanks. I don't know if I can make this work either. All right, well, I can't even see it from here. So anyway, what's going to happen here is the packet gets encapsulated with the header that looks like this, right here. Let's see if I can get that to happen, right there, right? That's what the packet looks like. That's just going to get sent across the internet as the network is today to 12002. And then at the other side, it's just going to get decapsulated, and the ETR over here is just going to decapsulate it and send it along. So it's pretty simple, right? Basically, you look up a host's IP address, turns out to be an EID, in the DNS. You send the packet along your IGP to the border. The border encapsulates the packet because it has this mapping entry. We'll see how we got that in a second. And then it just sends it across and decapsulates it. Notice that means that the EIDs, even though we're calling them identifiers, have to be routable in the inter-domain scope. So over here and over here, right? And then the RLOCs are routable in the middle. I don't know if this is working at all, but it'd be easier if the animation actually worked here. But okay, so that's basically the map and encap operation. So you can think of it as just send the packet to the border, encapsulate it to the other side, and decapsulate it. That's it. Now I'm an ETR, and I'm thinking, how do I get this mapping? I need that mapping to find the other side. Well, the system, we've tried a bunch of. Vince. Yeah, thanks. That'll be helpful because I can't really see it. Okay, so how do I find the mapping? Okay, so that's another part of this whole equation, right? Well, we've looked at a bunch of different mapping systems, and we've designed a couple, and the one that we kind of have settled on is called ALT, for alternate topology. So we call it LISP plus ALT, and basically it's a hybrid push-pull. The ALT infrastructure aggregates, and the LISP ITRs actually pull the specific mappings, right? So there's and we're trying to keep the EID prefix allocation hierarchical, because if we have that thing get completely deaggregated, then all we've done is move the problem we have in the core to the mapping system, and we don't want to do that because then we haven't won anything. So we're trying to keep the EID prefixes really coarsely aggregated. And the way we do this is that we just run it over a GRE overlay. So basically what the ALT is just an instance of BGP that carries EID prefixes that runs over GRE, and it's used by the ITRs to find the mapping. So basically it's just another instance of BGP. And this is going to be tough because, yeah, all right. I don't think I'm going to be able to really give you a feeling without the animation here, but let me see if I can do it anyway. So basically what happens here is same situation before. the host on the left, that would be on the left, your left, so where it says ITR, it would look up the destination address, which is 240.111. And basically what that ITR would do then is it would say, okay, it would say, okay, well, I got to find a mapping for this thing, because when the packet gets to the border, if it doesn't have a mapping, it's got to go look it up, right? So it's looking it up, and the way it's doing it is it sends a map request to the other side. So this packet that, I don't know, I think I could use the pointer myself if I have it. You got it? Okay. So the packet looks like outer header has 11.001 in it, and the destination is 240.111. Now, the interesting thing is you send this packet on the alt, right? And the alt itself is carrying the EID prefixes. So basically it routes the packet just like BGP does to the person advertising it. Well, who's advertising it? Well, it's the ETR on the other side. So the ETR on the other side of this, on the right side, it's really too bad this animation isn't here, but on your right side, gets the packet, right? And then it gets this map request, and it sends a map reply back. Okay, so there's a request reply thing here, and you can't see it because you can't see it. But anyway, that's the way it works. And I'll put these slides up somewhere. But I don't want to spend more time on this now because this is kind of broken and it won't help. But basically, the idea here is the ETRs advertise the EID prefixes that they're authoritative for. When an ITR gets a packet that it doesn't have a mapping for, it sends a map request onto this alt thing, again, which is just an instance of BGP that runs in a separate VRF over GRE tunnels. That routes the map request packet to the ETR that's authoritative for it, and it sends a map reply back. And then all of a sudden, the ITR has the mapping, and it can encapsulate the packet and send it directly. So that's how that works. It's not, the picture kind of looks complicated here because I think it crushed the whole animation into one slide, but maybe it should have. So that was going to be my tutorial on this. So since my two slides that were crucial to that weren't there, maybe I'll just take a quick break and kind of get an idea. Do people have a sense? You're not going to know exactly how it works now, but do you have a sense of what it does? Basically, on the data plane, what you do is you encapsulate the packet and send it to the other side and decapsulate it, right? It's pretty simple. In the control plane, the alt, you advertise as an ETR what EID prefixes you're authoritative for. And then when I'm on the ITR side and I've got a packet and I don't have a mapping for it, I just send a map request into the alt, which because it's just an instance of BGP on this other address space, the packet finds its way to the authoritative ETR, which sends a map reply back, and then the guy has the mapping and can encapsulate the packet. That's about it, really. It's the whole thing. Of course, as always, the devil's in the details. Okay. So what does that look like? Okay, so we took this approach that rather than writing up a bunch of paper, well, we wrote up a bunch of paper too. Who are we kidding? We made a lot of paper, but we really wanted to put something into the field that we could see if it would really work and get some experience with it, because a lot of these things, there's a lot of study and a lot of paper, but what we found is by trying to implement it and trying to deploy it, we've learned so much. And I wanted to show you how far we've gotten. We have like 25 sites up right now, and they're not all IPv6 sites, but we have IPv4, IPv6, and mixed. So you can get on the www.lisp4 and kind of see this picture in a little bit more detail. So here's our deployment model. This is stuff I wanted to talk about. Right now, what we're doing is we have the implementation running on 1RU PCs. They're called Titaniums. I'm not exactly sure why. It's just a 1RU PC with some giggy interfaces on it. There's a Lisp-capable version of NXOS, which Dino's developing, and then there are iOS implementations that are underway. We want to see if we can run it in a ISR's class box. And there is an open source implementation that's semi-complete. I think it's one spec revision out of sync right now. So those guys need to get the latest spec and upgrade. But they had it up and interoperating with the previous spec revision. We made a change. I don't know if I have this in here, but we made a change in the packet format. So you might have thought of this while I was saying this. So we could piggyback the mapping data on the map request, because if I send you a map request because I want to talk to you, what are the chances you're not going to want to talk to me? Pretty low, right? So why don't I just send the mapping data that you're going to ask me for anyway on the map request? That was the change we just made. And that idea came from Noel Chiappa about a year ago or something when we were working on another mapping system, and we kind of finally got around to incorporating it. So that's sort of the hardware-software environment. Endpoint identifiers, remember I was saying we really wanted to keep these aggregated, because if we don't do that, we'll just move the problems that we have in the DFZ right now into the mapping system. So we're trying to do this geographically and kind of along the lines of the RIRs. So that's kind of the idea we have. And basically then we have these boxes that we're calling alt aggregators, which are trying to aggregate these things up either continentally, regionally, or things like that, you know, basically geographically, and they're placed strategically around. And then we have this GRE tunnel topology. Remember, the alt runs over this GRE topology, and basically it's partially meshed at the top. So these alt aggregators, continental level things, or roughly continental level aggregators, are all kind of partially meshed together, and then all the sites are kind of on stars around those things. I wanted to mention one thing is that the alt actually doesn't require you to use GRE. You just need some tunneling technology that will allow you to decouple the actual physical topology from the alt topology. So in some cases, like in my test bed thing, I have it running on .1Q in some places. So we've also been thinking a lot about inner working. We were thinking about transition. I think we started thinking about this as transition, you know, but like the IPv6 transition schemes, transition might be forever. So we might as well call it inner working. So we have two ways of doing it. We have what we call Lisp translation, and that's just Lisp NAT, and I'll show you that later. And then we have proxy tunnel router, which is basically a box that what it does is it aggregates the EID prefix into the DFZ, not also into the alt, but into the DFZ to attract traffic from the outside internet to this box. And once it gets there, then it just behaves like an ITR. So that'll allow you to talk to Lisp sites from outside the Lisp world. There's also this other thing about inner working that we were looking at. So there's inner working between Lisp and non-Lisp sites, but there's also 4 and 6. So you might want to say, I want to send a map request, I want to respond to a map request for an IPv6 EID prefix, or EID, with a v4 locator, and we're calling these mixed locators. And the point of doing this is so that you can connect IPv6 islands over IPv4 without an intervening native IPv6 capable network. And we'll see a little bit more about this in a second. But these are the kind of things we've been trying to do. Trying to think through, you know, how are we really going to get this deployed? So we have some network numbers too. Here's what we did. So Andrew Partan, we were sitting around in IETF or something talking about this, and he goes, oh, well, I happen to have a /16. I go, oh, okay, that's cool. And it's this, 153.16. If you look at it, if you whois on it, you'll find some information about the varied history of this thing. And then I got this /32 for IPv6 from Aaron. It's experimental. It's experimental allocation. So both of these turn up in the DFZ for inter-networking purposes. Andrew's advertising 153.16, and I'm advertising the EID prefix. We want to advertise this, both of these prefixes with a consistent origin from various places around the network, so we'll have sort of an anycast effect. We're numbering the tunnels out of 240/4, and we're using 4-byte ASNs, and the format we're using is shown there, but you know, that's just what's implemented right now. Whether or not we do AS plane or whatever, it depends on how it all goes. But that's just the format we're using for now. So we have some names out there too. Lisp4.net has the IPv4 Lisp EID prefixes in it, and there's one exception. If you look at www.translate.lisp4.net, that's I think it's in 128.223, 156.57 or something. But basically, this is just the upstream router that has that points at the Lisp NAT, just like the standard NAT would do it. And then the IPv6 EID prefixes are in Lisp6.net. You know, as you might imagine, Lisp.net was gone. The Lisp people, the Lisp programming language people were not happy. I thought it was more fun than they did. So how do you do this? I mean, if you want to build this, how do you actually configure this? Well, it's pretty simple, really. There's a lot of machinery here, but most of it's pretty straightforward. If you want to enable the the IPv4 list by TR, you just say IPv4, IP list by TR. For historical reasons, the implementation we're working on, IP means IPv4, and IPv6 means IPv6, surprisingly. So you just turn it on like that by saying IP Lisp ITR, and you got an ITR. We put the flexibility in so you could use another VRF to resolve Lisp mappings if you wanted to, but for now, we just tell it, use the Lisp VRF we're calling Lisp, and that's the one that all the ETRs inject their EID prefixes into. Early in the process, and this had a lot to do with the talk thank you, what went on in the RRG, but basically there was a lot of talk about what do you do when a packet hits an ITR and there's no mapping? Do you drop the packet? Do you queue it? What do you do? And what we did was we said, okay, well, we don't know. So what we'll do is we'll allow you to piggyback the data on top of the map request, or underneath it actually, and send it over the data plane. And we were calling that data probe. So basically what you would do is you just decapsulate the packet at the ETR and send the data on to its destination, even though it was on the control plane and not the data plane. But we've kind of deprecated that. So when you get yours, don't turn that on. So now on the ETR side, same thing, turn it on, ETR, IP ETR Lisp or IPv6. But this is the kind of interesting part. Remember I said the ETR has to be authoritative for some mapping. So basically the way it looks is, the way we kind of worked on it for now is, you say IPv6 or IP Lisp database mapping, and then you give it an EID prefix, again in green, and an RLOC in red. And then there are two other parameters that you can give it, priority and wait. Priority tells the ETR which ones to use first. So if you have a priority 1 and a priority 2 mapping, if the locator for the priority 1 mapping is down, it will use the priority 2 one. Otherwise, it'll use the 1. So higher is used first. And then wait is a percentage of the traffic that's going to that EID prefix that should be sent to the RLOC. Now notice that if you have 2, you could do load splitting, and by telling it 50-50, and I'll show you an example of that, and you won't have to inject more specific prefixes to accomplish that. In fact, you can do active-active, which is pretty tough to do, if not impossible. So this is an instance, this active-active BGP-free multi-homing is an instance of a side effect that we probably didn't realize when we first started designing this that we could do, because we have this additional level of indirection. So, as I said earlier, the ETR typically advertises its EID prefix, whatever it's authoritative for, into the alt, and that attracts the map requests, right? And then if you want to do this mixed locator thing I was talking about before, you could do it like this. This is what I have, I think, on, well, I'll show you this, and then I'll tell you where this is. Basically, what I say is, I said, okay, I have this prefix, this /48, 1200/48, and the locator for that on IPv4 is this 128.223, 156.134. And I said, use that one first, right? Wait, priority 1, wait 100. And then the other one is just do the same thing only with IPv6, but don't use that one unless the IPv4 one isn't there. So what this has the effect of doing is, when I send a map request for this EID prefix, I send it back over v4, right? So, or you can send it back over v4. And if you want to force that to happen, you can tell it by saying IPv6 Lisp ETR, send it over IP. Remember, IP means IPv4, not IPv6. So we're able to kind of connect. We can kind of do 4/6 pretty easily, or I haven't really tried 6/4, but that ought to work too. 4/6 works pretty easily. Oh, okay, I wanted to show you this because this is kind of the way a typical ITR, I think this was mine, would advertise its EID prefix. I just happen to be using this technique of putting a static route to null 0 with a tag in it, and then I just find that tag and stick a community on it so that BGP can find it. But the real one that I thought was kind of interesting was, so this one where I have neighbor VRF lifts, neighbors FC00, blah, blah, blah. So basically what I wanted to find out is whether or not we could use private addresses in different places in the alt and what would happen and what was the significance of those. And basically it works just as you might imagine. It doesn't matter. It just works because the significance of that address is only between the two endpoints. So it seems to be pretty robust to the addressing format there. And then the rest of it is just standard BGP stuff, as you guys know. So we're trying to do another thing too, which is a low OpEx version of all of this, because at the end of the day, if it's CPE based, it's got to be pretty cheap and easy to do. So the way this thing works is, on the low OpEx XTR, it doesn't run BGP. So what you do is you put a static route to the entire EID space, both IP and IPv6, to the other side of the tunnel that you have. Okay, so that's what these first two lines are. So just take the whole /16 and send it, right? That's like a default route. And then on the upstream alt aggregator, just point the specific that this site, 10 minutes, okay. The specific that this site is authoritative for back down the tunnel. So that's how I did this. And this is just like, you know when you have a customer that you're static routing, it's exactly the same. Okay, so let me blast through some of this because I want to see how you guys think about these sites. Okay, so this translate thing is inner working, right? And basically, here's how I don't have that much time left and I want to rip through this, but basically, look at the middle bullet. This is how I configured this thing. I just said, here's the mapping, and then on the let's see, I don't have it, but the third line in the middle bullet, it says IP list translate inside outside. That's it, NAT, right? And then if you get on www.translate.lisp4.net, you can get on it right now. That's NATed. Lisp, it's translated, right? So basically, I have three ways for you to get to that site: NAT, PTR, and IPv6, and I'll show you. So this is the first one. So here's the PTR thing. So it aggregates the most coarsely aggregatable EID prefix into the DFZ. That causes any packet to the Lisp EID space to go to the PTR. When it gets that traffic, it goes, oh, it's Lisp traffic. It just behaves like an ITR, encapsulates it. It does a map request, encapsulates it, and sends it to the other side. And the important thing is that the PTR doesn't really get mapping state. It doesn't have any. And so how did I do this? Well, here, it's like we worked a lot to get this to work, but now it's all boiled down to this. Here's the compiled version. You tell it to use the Lisp VRF, and then you tell it it's a proxy ITR. So if you get on, you can get, trace routing to either of these would be interesting too. But basically, if you get on either www.lisp4.net, that will use the proxy tunnel router that's at Andrew Partan's house, because he's advertising 153.16/16. We want to get some more of those up and running just for robustness, and because the stretch involved has to do with how far the endpoint is from where the PTR is. And then if you look at www.lisp6.net, that's IPv6 PTR that's at the U of O right now. You'd be surprised how hard it is to find IPv6 connectivity. So we have some futures. I don't know how much time I have left.
15 minutes.
15?
12.
12. Okay, good. Hopefully we'll take some questions because how this all works part crashed and burned. So what we want to do in the future is we want to kind of continue to develop Lisp, the software, right? I mean, software-based is always an issue. So we have NXOS, we have iOS, we have OpenLisp going on. A couple of people have talked to us about other implementations as well. By the way, Lisp is a totally open thing. It's not a Cisco thing. We're not taking IPR on it. Everything that we have is published in the IETF. We want to encourage people to work with us and contribute, and we want to contribute back. So the recent packet format changes I mentioned, and that's in the newest spec that I think Dino just published yesterday or the day before. Basically, it's all about piggybacking the mapping on the map request, because, right, if you're going to talk to me, if I'm going to say I need to talk to you, you're probably going to want to talk to me, so I'll just send you my information when I send you my request for your information. We want to continue to build out the network. We have some new sites. Level 3 in London's up. Aaron, I don't know where their box is. It's in flight somewhere. I think Roque actually got his for Uruguay. Did you get it, or do you have it? Or shipping stuff to Uruguay is interesting. And then there's several other ones in flight. But let us know if you're interested. We're always looking for new sites and new people to work with. One of the things we really want to do is simplify the alt and how it works. Some open questions, okay? Who runs the mapping system, right? And what's the business model for whoever runs it? Our kind of idea was maybe it'd be natural to have the RIRs run it. And that's why we're trying to get involved with RIPE and Aaron and all this, and all this kind of stuff. But, you know, those are still open questions. Is the mapping system too complicated? It's complexity issues. I'm always really sensitive to that, so I kind of always look at that and go, I'm not sure. Negative map replies, that's an interesting one. So you're an ITR, you're sending a map request for a piece of the EID space that doesn't exist. There's nobody there. How do you know to stop sending them? So what we didn't want to do was, in the alt router is just a BGP router. Right now it doesn't know anything about LISP. And that was kind of a feature. We liked it because, you know, you could use a Zebra box or a Quagga box or anything, or any other box in there to run that, right? If it needs to return negative map replies, then maybe it's not going to be able to be a generic BGP speaker. And we're trying to avoid that and think of ways to accomplish this by, you know, sending back coarse aggregates that the ITR could know were not there. That's tricky, though. There's some ideas about how to use LISP for IPv4 address space conservation. You'll be seeing that in internet draft format, I hope, pretty quickly. There's issues about what is the effect of the mapping system on applications, in particular, you know, if you have to drop the first packet because you don't have the mapping, or what about the latency induced by just doing the lookup? There's other issues about the scalability of the alt. What happens if it degenerates into what we have in the DFZ BGP right now if we want anything? Path MTU effects. You're putting another header on the packet. Are you blowing up the MTU too much? Stretch effects. How much long path routing is going to go on here? How about caching and the XTRs? There's the point of this slide is that there's a lot of stuff to think about here. Here's the internet drafts that are out there. The top one is the base spec. The draft fuller, excuse me, that's the alt spec. It's pretty straightforward. It's easy to read. The inner working spec is this draft Lewis one. And then I wrote this thing. It's really kind of trying to put a stake in the ground saying I need an EID prefix allocated by the IANA. That's what draft Meyer Lisp EID block is. But really I went out and bought one because I couldn't get them to give me one. So I got $500 extorted from me from Aaron so I could use the /32. Apparently they're rare or scarce. And then Luigi and his crew in Brussels have this open Lisp implementation. In fact, they have a really kind of an interesting idea about how to use DHT as a mapping system too, although it's not well cooked. It's shown there. And then these ones in red are some other things we tried when we were in the early days when we were thinking about different kinds of mapping systems. So that's about it. Get on lisp4.net or lisp6.net. See what you think.
Vince Cerf again. I wasn't quite sure when I looked at the endpoint identifier idea and your concern about not having a big flat cable. How are you thinking about mobility and people moving from one part of the net to another and trying to carry the EID with them? Is there anything there, or are we thinking fixed installations more than mobile?
Well, so mobility, yeah, I should have mentioned mobility as one of the open questions. We had a couple ideas about mobility. One is you could rehome because you're topologically disconnected, so you could keep the alt being aggregated that way. But you can, there's a couple of other ideas we had thought about, which include like making the ITR notice that you've moved and trying to make sure that you don't inject that inject the longer prefix into the alt. Because if you do that, I think your question is, if you have mobility, let me see if this is what you're driving at. If you have mobility, it's going to just fragment the address space like it is today, right? And that's what we're trying to avoid.
Todd Underwood. So, Lisp, I appreciate the revamp even without the beautiful animations. Sorry about that. The Lisp
no problem.
Hasn't, although I think it's made a certain amount of buzz, it's also getting, I mean, maybe not in public, but I hear a lot of fairly widespread private kvetching about it. And some of that's just sort of free-floating kvetching about map and cap in general, and people don't like it, and it's either confusing or it's bad, or we tried it a million years ago and it didn't work, or there's a lot of... So I wonder if you could sort of lay out what you think are the most common objections to LISP that you've heard, and just line them up and knock them down.
Well, that's an easy question.
It's the exact tactic for,
Yeah.
doing presidential debates.
Yeah. Let me do a few of them, and can I ask the rest of the LISP crew, because they can get up here and think of things too while I'm thinking. So if any of you guys have an idea you want to, I'll give a couple. One thing I've heard from a lot of people, and I've heard this in various contexts, is that anything you do, LISP intends to extend the life of IPv4 and help it to scale. One thing I've heard is that anything you do to, try to shore up IPv4 is really damaging to IPv6 deployment. I've heard that from a lot of people, and I don't really buy that. Okay, so I don't know. That seems like an opinion and not a technical complaint to me. That's one. I think I mentioned the PathMTU one. People, in fact, there were some complicated specs that came out about how to do this PathMTU stuff. And basically what we decided to do was, something really simple, like if you have a packet that goes over a certain size, break it in half, rather than to put a bunch of protocol machinery in there to solve a problem that may or may not be a problem. A lot of people have said that the alt is too complicated, or that the EID prefix allocation could never happen the way we were envisioning it. These kind of things. And those are legitimate concerns, but as I mentioned earlier on, one of the reasons we've done this the way we have is because we wanted to get deployment experience rather than, the Gedanken experiment or whatever. So, those were issues. Do you have something?
I was just going to comment, you said this has been done before but hasn't been successful. So the idea has been around for a long time. It's been around for a long time, and it's only really been done in the host. This is the first time it's actually been done in the network, so we don't have to change hosts. And very much, when you want to do an incremental solution and IPv4 is pretty much a swamp of prefixes and we try to do the best we can, we think we can do this much better with IPv6 because things like, is a destination site LISP capable or not, you can just look at the prefix and it can be hard-coded, where all the prefixes that IPv4 uses that EIDs would have to be put in a really large table, so we have to put mechanism in the network to do that sort of thing. So in a nutshell, this is the first network-based locator ID split.
Others? Okay, well, thank you.